I'm going to try to make some sense out of this LinkedStack. We previously worked with a container class called Stack, okay? And that actually had, what was it, a vector of different types of stuff that we could put in here. It's a little different because we're going to have pointers pointing to pointers, pointing to pointers, and hopefully I can make some sense out of this for you, okay? I'm starting out here. Excuse me, this is the test driver. It says a stack of 20 strings. It's not creating any stacks of any size, okay? It's quite confusing, okay? But hopefully after this video, I'll be able to show you how to do it. And when we're working through it, hopefully we can understand it all. The textbook gives us this starter, this link stack to start with, okay? And it starts out with, we have two different we got a structure in here and we got a class in here, okay? The structure is like a bunch of little things, and then we're going to kind of store them in a class, but we're really just storing pointers, okay? But anyway, let's get back to this again, okay? A structure is just like a class, but if you look at the definition, it'll say usually all the variables are pointers, okay? And in this case here, we don't have any private variables. We got two public ones that we can get at. One is called data and one is called next. Now, I really don't like next, okay, because next is really previous, okay? What we're going to store in here, we're going to store a piece of string data. If we look at here, we're going to be storing like A, B, C, D, and things like that, okay? And, oh, yeah, don't worry about that for now. But anyway, it's going to store that letter in there, okay? And this is going to actually store the previous node, okay? Because we're going to make a bunch of these as we go along, okay? And as we do, once again, it's going to store that letter. And this, we're going to later on say, okay, what is the previous node? Because that way we're able to back up through our nodes, okay? So remember, next is actually previous, okay? Now what we're going to do in this link stack here, okay, is we don't have a list, array, we don't have anything like that, okay? But what we're going to do is store pointers to the top item that's in our list, okay? It's all kind of like, it's weird, but we're going to do it together, okay? So anyway, this stores a pointer to the very last piece of information that we put into our list, okay? And so we're going to be using this. And then what we're going to do is down in here later on, we're going to store that, okay, let's make this one the top one now, okay, and let's store the previous pointer in next, okay? Okay, here we go. Let's try to work through this, okay? Starting out, we're going to send a pointer, set the top pointer to null pointer, okay? And let's just do that a minute here, and we're going to say top. Top is a pointer variable within this class link stack, okay? So let's create a pointer. Once again, pointer points actually to the memory location of a node, okay? Of a node, okay? And so we're going to say top, which is a pointer, is equal to a new node, okay? Semicolon. Now when we do that, we're calling the top constructor here, and you notice that the top constructor here doesn't put a value in it, okay? So what we're doing is we're basically creating something with nothing in it. Once again, it puts in null pointer here because we don't know. In fact, if we don't have anything in there, there is nothing to point at previously, okay? So therefore, we're putting a null pointer in to start out with. So when we do this, we create a new node with our constructor, okay? However, there's no information in it, and there also it's not pointing to anything previous because once again, we don't have anything in there. Now, later on in our program here, excuse me, in our class, we're going to be wanting to know if something is empty, okay? The easiest way to do that is say, okay, is this pointer in here, is this null pointer top equal to null, which at this point it is, okay? Because we haven't set it, okay? And so therefore we're going to say something like this, return top is equal to null pointer, PTR, like that, okay? So in other words, is there nothing in here? We aren't pointing at anything. And yes, at this point, there's nothing in there, okay, because we haven't added anything yet, okay, so it is empty. Now push is the one that's going to put something at the top of the list, okay. If the top is equivalent to a null pointer, let's write some code that says something like that, okay. If is empty, we can say that, okay, because there's nothing in there. Then if is empty, once again, we're calling that method, okay, right up here, okay, if it's empty, okay, then go ahead and take that first one that our constructor built, okay, and put a value in there, because right now there's no value in there, okay. So let's go ahead and say top is equal to a new node, and this actually put a value in there, okay. And what's our value going to be? We're passing it element. Once again, element is going to be like one of these letters, okay? And so we're going to say node, not node, okay? And then send it element. Okay, like that. Wonderful, okay? So now what we're doing is we're saying, okay, create a new node and make top, this pointer here, point to that node. Okay, let's keep going here. Maybe it'll come clear a little bit later, okay? Else, if it's not, okay, then we have to create, then we got to do some more stuff, okay? Else, okay, and this made a temporary node, okay? Temporary node, which a node pointer, node pointer, okay? Temp is equal to the top, okay? Let's save that because we're going to have a new top now, but we want to retain that because we're going to put that in next here, our previous, which I previously said. This is stupid. I don't like next. But it's basically we're going to save this pointer because this is now going to be the previous pointer. Confusing, thick as mud. I don't like this assignment. Anyway, continuing on, okay, we're going to put that in temp. And now let's do this just like above. Oops, I'm sorry, top, okay, is equal to a new element. If I got talking right at the same time, like that new element, okay. Excuse me, a new node, I'm sorry, node, like that element, okay. So let's create a new one, okay. So this pointer is going to point to a brand new node. Really weird, we don't have an array, we're just pointing to a whole bunch of nodes, and then this next is going to point at the previous one so we can back up when we need to, okay. And then we're going to say, okay, top, right here, top. Okay, now we can't call next, okay? You can't call next when you're doing pointers. Next, once again, would call this public variable here, okay? We can't call top. In fact, if we did this, it's really kind of funny how the compiler does this, okay? If we said, say, top dot next, okay, there it is right there, okay? Look at that. It makes this little pointer for us, okay? And it's pointing to the pointer can't look at a variable. However, it points to the object that's saved, that node, okay? And it's then giving us this variable next within that. And that is going to be equal to temp. And that is how we save the pointer to the previous one. Once again, we're putting it in the previous. We're saving this pointer to the previous. So now when we take and move it back, okay, then we just say, okay, the next is now equal to the temp, which would basically kick out the one that we just did. Anyway, there you go. There's the code for that, okay? Continuing on, okay? The next one is this peak, okay? We just want to return the value that's in the top one, okay? So we're going to say return, okay? And we're going to say, well, our pointer to that highest node on our list, or what do you want to call it here, dot data. And once again, you're going to see it replaces it with this because a pointer cannot look at a variable. However, it points to that data, that variable and it gives us data from that, okay? Semicolon like that, okay? And now this pop thing. The pop thing is the hard thing because what we want to do is we want to pop off, get rid of that top element, but we want to go back to that pointer called next, which is really the previous element. I'm shaking my hands over here trying to explain it. It's so much easier to do this in class, but yet we're doing it online and we're all going to work through it together and you're going to end up with a code and you can turn it in. Everybody's happy, okay? So first thing we have to do when we do this is that we have to create a temporary string, okay? So we have to do std because we didn't say using namespace up here, okay? Let's say std standard : string, okay? So create a string variable called temp, and that's going to be equal to top, and then we can say dot data, and of course, once again, it's going to replace it with that minus greater than, okay, dot data semicolon. So now I'm saving the A, B, C, whatever letter was saved in there to a temporary string, okay, because we're going to return it in just a minute. Now, this pointer up here called top, we want to make that equal to the previous, or the pointer to the previous item that was in there, okay, which is called next of all silly things, okay. So anyway, we're going to say top, come on, fingers, top, is equal to top, okay, our current top, dot next, right there, look at that, like that, okay, semicolon. So now we're going to say make top equal to the previous pointer that we had, which should move us down one step from the top. Anyway, and then we're going to return temp, okay, semicolon like that. And that's it. Go ahead and run your program. It should work. If not, go back and look at the code, and you may have made a little table. This is hard, and I wish we would be in class so we could work through this together, but it's not. I just spent 12 minutes talking. I'm going to stop.